Sir. Na-commute kayo, sir.
Okay na?
Okay na, sir. Thank you po.
Okay. Thank you. What about calcium? Si calcium nasa 20 sa periodic table. Mag-focus ka. Ayun. So number 20 sa periodic table. So that means ang atomic number niya ay 20. So ang bilang ng proton niya ay 20. Since stable siya, yun din ang bilang ng kanyang electron. For neutron, ang atomic weight ni calcium ay 40. Ang atomic number niya ay 20. So 40 minus 20, you will get 20 neutrons. You will be able to you will encounter elements na kung saan meron silang charges. For example, aluminum, positive 3. Calcium, positive 2. So si aluminum, meron siyang ion. When we say ion, it could either be positive or negative kasi ions are charged particles. Now, paano natin malalaman ang bilang ng subatomic particles ni aluminum positive 3? Ilan ang protons niya? How many protons does aluminum positive 3 have?
13.
Okay, correct, Gwyn. 13. Bakit 13 ang proton niya kahit na positive 3? Hindi po nababago ang bilang ng proton kapag charges. Ang nababago lang ay electron. Hindi pwedeng madagdagan ng proton kasi yung proton nasa loob siya ng nucleus at malakas yung humahawak kay proton at kay neutron, which is the gluon. So hindi madadagdagan ang proton at hindi mababawasan ng proton, electron lang. Now, the number of electrons for aluminum positive 3 is?
16.
Okay.
10.
Okay, correct. 10. Naging positive 3 siya kasi nabawasan siya ng electron. And remember that electrons are negative. For neutron, 14 pa rin. Hindi mababago. Kasi remember, sa charges, ang nababago lang ay electron, hindi ang proton at neutron. What about calcium? Ilan ang proton?
20, sir.
Okay,
20.
20. Ilan ang electron ni calcium? Positive 2.
18.
18. Correct. 18. Kasi nabawasan ng dalawang negative. For neutron,
Same.
okay, correct. 20 pa rin. So, yan ang summary ng Module 7, which is about atoms, ions. Isotopes will be discussed in Module 8. Do you have any questions so far? None. Now, there's a shortcut para malaman natin kung ano magiging charge. Okay. So, dito kay hydrogen, mula sa pinakataas hanggang pababa, lahat sila, ang valence electron nila ay 1. When we say valence electrons, these are the electrons that can be found in the outermost shell. Since nasa pinakalabas siya or outermost shell, siya yung nakikipag-interact with other elements to form compounds. So lahat ito, 1 ang valence electron. Mula kay beryllium pababa, lahat sila 2 ang valence electron. Dito kay boron, skip natin yung mga nasa baba. Kasi yung mga valence electron nila ay pabago-bago, kaya hindi fixed. Dito tayo kay boron. So mula kay boron pababa, 3 ang kanilang valence. For carbon pababa, 4 ang valence. For nitrogen pababa, 5 ang valence. For oxygen pababa, 6. For fluorine, 7. And then lastly, 8. Now, paano natin malalaman ang kanilang mga charges based sa kanilang valence electron? Always remember octet rule. Octet meaning 8. Kailangan niya ng 8 para maging stable. So dito, na isa ang valence electron, which is easier, ibigay yung isa or kumuha ng 7 para maging 8 ang kanyang valence electron. Which is easier, ibigay ang isa, kumuha ng 7.
Kumuha po ng isa.
Okay, mas madali na lang na ibigay niya na lang yung isa niya kaysa sa kumuha siya ng 7. So, since ibibigay niya yung isang electron niya, magiging positive 1. Dito naman, Dalawa ang valence electron, kailangan niya maging 8. So, mas madali ang ibigay ang dalawa or kumuha ng 6. Okay, magbibigay na lang siya ng dalawa. Since ibibigay niya yung dalawa, magiging positive 2 ang kanyang charge. Lahat naman nandito, positive 2 ang charges. Kaya makikita niyo positive 2. Next, for boron, 3 ang valence. Mas madali na ibigay na lang niya yung 3 kaysa sa kumuha ng 5 kasi outnumbered siya. So magiging positive 3 yung mga charges sa mga nandito. For carbon, silicon, germanium, 4 ang kanilang valence. Nasa kalahati siya. So pwede siyang kumuha ng 4 or ibigay yung 4. Depende sa kung anong element siya nakikipag-combine. So dito, positive, negative 4. Next, nitrogen, dito. In nature, 5 ang kanilang valence electrons. So, ano ang mas madali? Kumuha ng 3 or ibigay yung 5?
Kumuha ko ng 3.
Okay, kukuha ng 3. Since kukuha siya ng 3 electron para maging 8 yung valence niya, magiging negative 3. Dito, 6 ang valence, kulang ng 2. So, mas madaling kumuha siya ng 2 kasi ibigay yung 6, kaya negative 2. For fluorine, 7 ang valence, kulang ng 1, kaya kukuha siya ng 1, negative 1. And then lastly, dito, 0. Bakit 0 dito sa pinakahuli?
Sir, kasi 8 na yung...
Okay, correct. Kasi 8 na yung valence electron ng mga nandito. So, ibig sabihin, they are already stable. There's no need for them to react with other elements para maging stable sila. Sila yung mga taong kaya nilang maging maligaya kahit na mag-isa lang sila. Ganun yung stability nila. So, that is the shortcut para malaman ang mga charges ng mga elements. Para hindi nyo na kailangan gawin yung 1s2, 2s2, 2p6, 3s2, 3p6. Let's go to Module 8. Module 8 talks about percent abundance and isotopes. Ano bang ibig sabihin ng isotopes? Let's have hydrogen as an example. Now, hydrogen has 3 isotopes. This is prosium. This is deuterium. The third one is tritium. So, meron siyang 3 isotopes. All of them are hydrogen kasi isa lang ang kanilang proton. Yun nga lang, nagkakaiba sila sa bilang ng... Saan sila nagkakaiba? Bilang ng...
Neutrons.
Okay, correct. Neutron. Dahil magkakaiba yung bilang ng neutron nila, magkakaiba rin yung level ng pagiging stable nila or stability nila. The more neutrons na meron ng isang atom, the more unstable it becomes. The lesser the number of neutron, the more stable it becomes. So, ilan ang neutron nito, ni prosium?
1.
1. Yun yung kanyang atomic number. Kasi 'di ba, how do we get the number of neutron? Atomic weight minus atomic number. So yung 1 dito actually kay proton 'yan. So that means ang bilang ng neutron dito kay prosium ay 0. Wala siyang neutron. Siya lang yung element na walang neutron diyan. Next, what about deuterium? Ilan ang bilang ng neutron niya? Atomic
1 na 1.
weight, atomic weight minus atomic number, 1. Kasi 2 minus 1. The third one, 2 ang neutron. So sino ang ina-expect mo, sino yung ina-expect mo na mas stable or pinaka-stable sa kanilang 3? Sino yung expected na pinaka-stable sa kanilang 3?
Yung
Prosium.
Okay, it is prosium yung nauna. Kasi mas konti yung kanyang neutron. Samantalang dito, pinaka-unstable si tritium kasi siya yung may pinakamaraming neutron. Okay. Punta tayo kay calcium, ay kay chlorine. So si chlorine, meron siyang dalawang isotope. Chlorine 1735 and then chlorine 1737. Or you can simply write it down as chlorine 35 and chlorine 37. So these are two isotopes of chlorine. For example, meron kang sample ng gas. Meron kang sample ng chlorine gas. Kung sino yung mas stable sa kanila, siya yung kadalasan na mas marami. Now, in this case, 75.77% ang percent abundance ni chlorine. Ibig sabihin, ito yung kung gaano siya karami. Kapag meron kong 100 grams, 75.77% doon ay chlorine 35. Samantalang, yung isa naman na isotope ng chlorine, yung mas unstable, mas konti sila. This is 24.23%. So, ibig sabihin, kung meron kang 100 grams ng chlorine gas, mas expected mo na mas marami ang chlorine 35 kasi mas mataas yung kanyang percent abundance. At mas konti ang chlorine 37 kasi mas mababa ang kanyang percent abundance. So, how do we compute for their atomic mass unit or average atomic weight? In order to compute for the average atomic weight, kailangan nating makuha yung percentage, yung percentage ng isotope ng isang element and then i-add natin yun sa percentage ng another isotope. So dito, unahin natin ito. So 35 times 75.77% plus ito naman 37 times 24.23%. So saan nakuha itong una? Itong una ay nakadepende doon sa unang isotope ng chlorine. So 35 ang kanyang atomic weight, i-multiply natin siya sa kanyang percent abundance. So we are going to get the 75.77% ng 35. And then itong pangalawa naman ay nakadepende sa pangalawang isotope ng chlorine, yung chlorine 37. So 37 times the percent abundance of chlorine 37, which is 24.23%. Pag pinag-multiply natin ito, tapos kinuha natin yung sum nila, the average mass unit or the average atomic weight is 35.48 AMU. Pag percent abundance, ang unit natin dito ay atomic mass unit or AMU. May question dito?
Sir, gagawing decimal percentage.
Yes po, gagawin din po natin yung may percentage. Pero dito sa part na to, may katanungan? Madali lang? Okay. So dito sa una, kasi dalawa lang to. Kukunin natin yung percent. Tapos imumultiply natin siya sa atomic mass. So ito yung percent abundance nitong unang substance. Imumultiply natin ito dito sa mass number or the atomic weight ng isang chlorine. Tapos yung percent abundance naman ng isa, imumultiply natin dito. Pag nakuha na natin yung product mula dito and then dito na isotope, ipag-add na lang natin. Doon nakuha yung 35.48. So paano naman kapag hindi binigay yung percent, pero yung amount ang binigay? Hawakan ko na lang muna saglit. Okay. So for example sa magnesium, there are 3 isotopes of magnesium. Magnesium 1224 or simply write that down as magnesium 24, magnesium 25, and then magnesium 26. Kapag meron kang 500 grams ng magnesium ore, ibig sabihin hindi pa siya na-refine, hindi pa napaghiwalay yung mga components. For example, meron kang 500 grams ng magnesium ore. Doon sa 500 grams na yon, 400 grams ang kay magnesium 24. 50 grams ang nakuha mo kay magnesium 25 at 50 grams din kay magnesium 26. How are we going to get the percent abundance of each isotope?
Ipag-add po yung grams, tapos i-divide po yung given din sa total.
Okay, correct. So kukunin natin yung total mass ng mga substances. So kukunin natin yung sum nitong mga to, which is 500 grams, and then we are going to use itong 500 grams, itong total weight niya, pang-divide sa lahat. At since percent ang ating hinahanap, times 100. So 400 times divided by 500 times 100, this is
80%.
okay, correct. 80%. 50 divided by 500 times 100,
10%.
10%. And then lastly, we also have 10%. So yun yung kanilang percent abundance. Magnesium has a percent abundance of 80%, 25, 10%, 26, 10%. So that, yun lang yung mga problems involving percent abundance. Any question or talusable pa?
Usable, sir.
Okay, good. Talusable pa. Can I erase or na-screenshot nyo na? Okay na. Now, we are going to have a short computation on percent composition or percentage composition. Since what do you call this? Since ito yung last na topic na pinagawa ko sa inyo, I am hoping na naalala niyo pa yung mga processes involving computation of percent composition. So let us have an example. Let us compute for the percent composition of sucrose or table sugar. Sucrose has a chemical formula of C12H22O11. How do we get the percent composition of C12H22O11? Ano yung first step? What's the first step? Bilangin kung ilan ang atom sa bawat element. There are only 3 elements, carbon, hydrogen, and oxygen. So isulat mo siya ng pa-vertically. Next, bilangin mo ang element sa bawat bilangin mo ang bilang ng atom sa bawat element. For carbon, 12. For hydrogen, 22. For oxygen, 11. Next step, multiply each element by its atomic weight. When we say atomic weight, nasa periodic table of elements. Let's have an agreement na in computing atomic weight, we will get the 2 decimal places ng mga atomic weight sa periodic table. So for example, kay carbon, kunin mo yung 2 decimal places, so it will become 12.01. So times 12.01. For hydrogen, atomic weight niya ay 1.01. For oxygen, 16. Lahat ng mga weight na kinukuha mo sa periodic table of element, ang unit niya ay grams per mole. So, huwag kalilimutan magsulat ng unit. Your units will guide you sa mga processes or sa mga steps na kailangan mong gawin. Ngayon naman, ipag-multiply mo na. So, 12 times 12.01, this is 144.12. For hydrogen, this is 20,
22.22.
okay, 22.22 grams per mole. For oxygen, this is 170,
176.
okay, 176 grams per mole. Okay, cancel grams per mole. Ay, sorry, mamaya pa pala yun. So, ipag-add na natin ngayon. Kunin natin yung sum ng lahat. This is equal to 342.34 grams per mole. So, that means the molecular weight, pag ginawa mo to, ang tawag dyan, kapag nabuo mo na yan, molecular weight. So, that means the molecular weight of C12H22O11 is 342.34 grams per mole. Next step is to divide each of the elements with the molecular weight. Dahil tinatamad ako, lalakyan ko na lang. Pero hindi nyo ito pwedeng gawin, ako lang. So, divided by 342.34 grams per mole times 100 kasi percent ang hinahanap. So, cancel ang mga grams per mole. So 144.12 divided by 342.34 times 100, this is equal to 42.1%. For hydrogen, 22.22 divided by 342.34 times 100, 6.49%. 2 decimal places tayo. Next, 176 divided by 342.34 times 100.
51.41%.
Okay, 51.41%. So the total should be 100%. Ngayon naman, there will be instances na kung saan hindi equal to 100% kapag pinag-add mo yan. Pero okay lang yun. So long as 99.99% siya, 100 or 100.01%, okay lang, tanggap natin yung sagot nun kasi nagkaroon lang ng discrepancy sa rounding off. Okay, let's have another example. So next example is, how do you compute for the percent composition of theobromine? So, theobromine. So when we say theobromine, this is the substance present in chocolates that makes the chocolate deadly for animals. Kaya hindi pwedeng kainin ng mga hayop ang chocolate. So the chemical formula of theobromine is C7H8N4O2. So we are going to calculate the percent composition of theobromine. Let me just erase the writings on the board. Masyado ba ako mabilis mag-discuss or okay lang?
Okay lang po, sir.
Okay. Okay, thank you. So, ang first step uli, write down the individual elements. So, C, H, N, O. Kasi ito yung 4 na elements na makikita sa chemical formula. Bilangin ang atom sa bawat element. For carbon, 7, hydrogen, 8, nitrogen, 4, oxygen, 2. Next, multiply them by their atomic weight. For carbon, that's 12.01. For hydrogen, that's 1.01. Nitrogen is 14.01. Oxygen is 16. I-multiply na natin. Sorry, yung unit pala. Grams per mole. Okay. Gawain ng tamad. So 7 times 12.01, this is 84.07 grams per mole. For hydrogen, this is 8.08 grams per mole. For nitrogen, this is 56.04 grams per mole. For oxygen, this is 32 grams per mole. Next, get the sum of all the molecular weight. So this is equal to 180.19 grams per mole. Ito yung ating molecular weight. So that is how you get the molecular weight. Next is to divide all of the weights with the molecular weight. Times 100. So cancel grams per mole. For carbon, it is 84.07 divided by 180.19. This is equal to 46.66%. For hydrogen, this is 4.48%. For nitrogen, this is 31. Hindi na pala nakikita. 31.1%. For oxygen, this is 17.76%. Over 100. So lahat yan, ang total ay 100%. Do you have any question regarding the computation of percent composition? None? Okay. Take a screenshot if you need. If not, then we can proceed with the next topic, which is module number 10. It talks about weight, mole, and molecule. Kasi yung alcohol. Now, when we say mole kasi, it is used to represent the number of substance in a given object. Bakit hindi na lang bilangin kung ilan ang atom sa isang substance para hindi na kailangan gumamit ng mole? The number, kasi ang atom kasi, sobrang liit niyan. Just as what we have discussed before, you will need, kung sa ruler, meron yung centimeter doon, you have to divide the centimeter by 10 in order to get millimeter. Eh, ang atom, mas maliit pa sa millimeter. You will need to divide the millimeter by 10 million in order to get the size of the atom. Actually, even the most powerful microscope could not take a picture of the atom sa sobrang liit niya. So, that is why hindi convenient na bilangin pa isa-isa yung molecules or yung particles ng isang substance. That is why we make use of mole. So, pag sinabi natin mole, it is used to represent the number of particles. Just as how dozen represents the number 12 in an object. For example, sa isang dosena ng itlog, meron tayong 12 na itlog. Sa isang dekada ng taon, how many years ang isang dekada?
10.
Okay, 10. How many years ang score? Pag sinabi natin score, it is equal to 20 years. How many years ang century?
100.
Okay, correct. 100. How many years are there in 1 millennium?
1,000.
1,000.
Okay, 1,000. So we make use of these words in order to represent a certain number. Parang sa dozen, we make use of the word dozen para i-represent yung number na 12. Ganun din sa ating number of particles. We make use of mole to represent the number of substances in a given object. So how do we find out kung ilan ang grams sa isang mole ng object? So for example, we have 1 mole. Mole can be written as MOLE. Shortcut niya is MOL or N. Kaya nalin dyan sa tatlo. How many grams are there in 1 mole of carbon? Okay. In computing for this mole, there are 3 formulas that you should remember. Sorry, there are 2 triangles na lang that you should remember. This is mole. This is weight in grams. the weight should always be in grams, and this is molecular weight. The other triangle is this is molecule, this is mole, this is Avogadro's number. So yan yung dalawang triangle na kailangan yung i-memorize. Okay. So dito naman, how many grams of carbon are there in 1 mole of carbon? Ano ang nawawala? Ano ang hinahanap? Grams, di ba? Or yung weight. So takpan natin yung weight. So mole times molecular weight. Kapag kung ano yung nawawala, yun yung takpan. Kapag nawawala yung weight, kapag hinahanap yung weight, then mole times molecular weight. Pag nawawala yung molecular weight, it is weight over mole. Pag nawawala yung mole, then it is weight over molecular weight. In this question, ang nawawala ay yung weight. So since magkatapat sila, then that means mole times molecular weight. So 1 mole of carbon. Next. Tignan natin yung atomic weight ng carbon. The atomic weight of carbon is 12.01 grams per mole. Now, this can be written as, for every 1 mole, there are 12.01 grams of carbon. So this can also be written as, in 12.01 grams in 1 mole. Pwede rin siyang isulat na sa isang mole, merong 12.01 grams of carbon. So dito sa dalawang ito, ano ang gagamitin natin para dito? Para sa computation dito? The left one or the right one?
Left,
Okay.
sir.
Yung nasa left. Okay, kasi di ba 12.01 grams per mole yung nasa periodic table. Okay? Now this can be written as, there are 12.01 grams per 1 mole, or in 1 mole there are 12.01 grams. So these two are the same. Yun nga lang kasi dito ang given ay mole. So that means dapat ang denominator natin ay mole para makansal yung mole. So dito sa dalawang to, kagaya ng sinabi ninyo, yung left side ang gagamitin natin kasi siya yung may denominator na mole. So isulat 12.01 grams in 1 mole. Cancel mole, you'll be left with grams. So 1 divided by 1 times 12, this is equal to 12.01 grams. So that means in 1 mole of carbon, you will have 12.01 grams of carbon. Talusable? Let us have another example. Okay. 3.05 mole of NaCl. How many grams are there in 3.5 mole of NaCl? So write down the given, 3.5 mole. Next is kukunin natin yung molecular weight ng NaCl. For Na, isa lang yun nandito. So 1 times the atomic weight of Na, which is 22.98 grams per mole. Next, si chlorine naman, isa rin. So it is 1 times 35.45 grams per mole. Ano ngayon ang atomic weight? Ano ngayon ang molecular weight ni sodium chloride? So ipag-add na lang natin to. So this is 58 point, mga
33.
bata. Okay, 58.43 grams per mole. Now, 58.43 grams per mole, this can be written as 58.43 grams over 1 mole or 1 mole over 58.43 grams. Alin ang gagamitin natin doon sa dalawa? Yung grams ang denominator or yung grams ang numerator or yung grams ang ano? Yung mole ang numerator or yung mole ang denominator?
Oh, yun din namin.
Okay, mole ang denominator. So 58.43 grams over 1 mole. So that means 3.5 cancel ang mole. So that means 3.5 divided by 1 times 58.43. This is equal to, kailangan ko ng calcu. So 3.5 times,
16.69.
so 3.5 divided by 1 mole times 58.43. This is 5, 10, 15,
204.51.
204.51 grams. Paano natin malalaman kung anong formula ang dapat gamitin? Balikan natin to. Weight ang nawawala, so mole times molecular weight. Talusable for now. Any question po?
Talasable, sir.
Okay. Okay nang irisin ko?
Yes, sir.
Okay. Mag-try tayo ng mga elements na mayroong parenthesis. Or mga compounds na may parenthesis. So 3 mole of aluminum fluoride. Ay, sorry, walang parenthesis yan. So 3 moles of aluminum nitrate. Paano ngayon kapag may parenthesis? So una, alamin muna natin yung formula natin. Ang hinahanap natin dito ay grams. So using the formula, weight, mole, and then molecular weight, nawawala yung weight kaya mole times molecular weight. So dito, so ano ang molecular weight ni aluminum nitrate? Si Al, si nitrogen, and then si oxygen. Ilan ang aluminum natin?
Isa.
Isa. Wala siyang substitute ng small number kaya it is understood na 1 ang number ni aluminum. Si nitrogen, ilan?
3.
Okay, paano naging 3?
Dinistribute ko yung 3.
Okay. Yung number na nandito sa labas ng parenthesis, i-distribute yan sa lahat ng element na nasa loob lang ng parenthesis. But si aluminum, hindi nakasama. Bakit hindi naging 3 sa aluminum? Kasi nasa labas siya ng parenthesis. Ang i-distribute lang natin ay yung nasa loob. So itong 3 mapupunta kay nitrogen at kay oxygen. So therefore, the number of nitrogen is 3. The number of oxygen is originally 3. Pero, yes, magiging 9. Kasi 3 times 3, it is 9. So this is 26.98 grams per mole. This is equal to, times dapat. 3 times 14.01 grams per mole. And then 9 times 16 grams per mole. Okay. Next, 26.98 times 1, this is 26.98 grams per mole. Next, 3 times 14.01, this is
42.03.
42.3.
40.
42.03.
2.03 grams per mole. For oxygen, 9 times 16.
144.
Okay, 144 grams per mole. Kunin natin yung sum ng lahat ng yan. So the molecular weight will be equal to
213.01.
238 point,
213.01.
213.01 grams per mole. So meron na tayong mole, meron na rin tayong molecular weight. So using the formula, it will be mole times molecular weight. So 3 mole of AlNO3 times 213.01 grams per mole. This will be equal to, cancel yung mole, you'll be left with grams. This will be equal to 639.03
639.03.
grams. So yun na yun. Ganon kumuha ng weight kapag ang given ay mole. Okay po ba? Madali lang?
Yes.
Okay. Paano naman kapag ang given ay weight? Okay, can you erase the writings na? Paano naman kapag ang given ay weight, tapos ang hinahanap ay mole? Erasin ko na.
Yes, ma'am.
Supposing that we have, asan na yung, asan yung marker? Supposing that we have 500 grams of water. We're going to convert this to mole. So using the formula, pag nawawala ang mole, it will be weight over molecular weight. This is our weight. We have to divide this by its molecular weight. So in order to get the molecular weight, si hydrogen at oxygen, dalawa kay hydrogen times 1.01, hindi pala nakikita, times 1.01, isa kay oxygen times 16 grams per mole. So this will be equal to 2.02 grams per mole, and this is equal to 16 grams per mole. Kunin ang sum, so this will become 18.02 grams per mole. So ngayon, i-divide natin yung 500 using the molecular weight. So 500 grams divided by 18 grams, ay 18.02 grams per mole. Cancel ang grams, we will be left with mole. Ngayon naman, another kasunduan. Kapag mole ang hinahanap natin, we will always make use of 4 decimal places para mas accurate yung values natin. Because in the next lessons, kapag 2 decimal places lang yung mole, magkakandaletse-letse din buhay natin parang nung gumamit tayo ng autoproctor. So, sa lahat ng mga moles na value, always make use of 4 decimal places. So this will be equal to 500 divided by 18.02. This will be equal to 27.69.
7469.
Okay, 7469
69.
mole. So yun na. How about the number of particles or the number of molecules? Now, the number of molecules or the number of particles, dinivise ang computation niyan ni Avogadro. That's why it was named after him. Amadeo Avogadro has devised a number of Avogadro's number, and Avogadro's number is equal to 6.022 times 10 to the 23rd power. Based from his many experiments, he determined the number 6.022 times 10 to the 23rd power as the number of particles for every mole of substance. So, ibig sabihin, constant na ito. Ngayon naman, pag i-convert natin ang mole to molecule, kung sakali na yung ating number of mole dito, we're going to convert that to molecule. This will be our formula. Nawawala ang molecule, so that will be mole times the Avogadro's number. Gets po ba? Or mabilis ako magsalita? So, in order to convert that to molecule, we have to multiply mole by Avogadro's number. So, times 6.022 times 10 to the 23rd power. So, 27.7469 mole times 6.022 times 10 to the 23rd power, this will be equal to 1.67 times 10 to the 25th power molecule. Pag na-compute mo na siya, pag na-multiply mo na siya sa Avogadro's number, ang magiging unit niya na ngayon ay molecule. So that means if you have 500 grams of water, that means you can expect to be able to count the number of particles as 1.67 times 10 to the 25th power molecules. Okay, now there will be instances na kung minsan yung iba nahihirapan sa paggamit ng raise to. Sa mga may calculator, you can make use of, for example, yung value 1. For example, ito yung ating nakuha na mole, di ba? And then we have to get the number of molecules by multiplying it to Avogadro's number. So ang gawin mo, 27.7469 mole times, ito yung ilalagay mo sa calculator, kahit na wag na yung mole, wag na yung unit. So ito yung ilalagay mo sa calculator, 27.7469, ito yung mole natin dito, times 6.022 shift log, and then the exponent, which is 23. Yung shift, pag gawin ng shift log, yan yung times 10 raised to. So, para sa mga may mga calculator ngayon or scientific calculator, yan yung i-input mo. Okay, so now we know how to compute for the number of molecules given our weight. Mula sa weight, ginawa natin mole. Ginawa natin siyang mole. And then from mole, minultiply natin siya sa Avogadro's number para maging molecule. Okay, last example. Paano naman kapag molecule ang given at ang hinahanap ay ang weight? Erase ko na yung writing sa board. Yan, okay na? Can I erase it now? Okay. Do not forget to click on the poll para sa attendance. So for example, we were given 3.86 times 10 to the 22nd power molecule of AlF3. I-convert natin ito ngayon sa grams. So, ito yung mga formula natin. Nasaan yung ating given? 3.86 times 10 to the 22nd power molecule, ito yon. I-convert natin siya sa grams. Ang grams nasa kabilang banda pa ng formula. So, ano ba yung meron sa kanilang pareho? Sa dalawang triangle, ano yung unit na meron sa dalawa?
Mole.
Okay. So, mole. So, ibig sabihin, by converting this value to mole, pwede natin gawin bridge yung mole to compute for the weight. So, ang gagawin natin, since mole ang hinahanap dito, takpan yung mole, the formula will become molecule divided by Avogadro's number. Okay? So, i-divide natin to sa Avogadro's number, which is 6.022 times 10 to the 23rd power. So, ang lalabas na dyan, kapag dinivide mo ay mole. Now, para sa mga gumagamit ng cycle ngayon, you can do this kung sakali hindi pa kayo masyadong bihasa sa cycle. I-input nyo ay 3.86 shift log 22 divided by 6.022 shift log 23. So, yan ang input sa mga scientific calculator. So, kapag ginawa mo yan, you will have mole as a unit. At since mole na siya ngayon, we need four decimal places. This will be equal to 0.0641 mole. Talusable? Any questions so far?
Sir, paano yung yung shift log? Kasi nakakaroon.
May cycle ka ngayon. Okay.
Yes po.
So sa cycle, yung paglagay mo ng shift log, yung shift nasa upper right corner ng calculator. So ilagay mo yung 3.86, pindutin mo yung shift log para lumabas yung 10. Kapag pinindot mo yung shift log, lalabas yung 10. Na kung saan yung 0 ay square. Ganyan. So ibig sabihin nito, raised to. Tapos yung 22, yun yung exponent natin dito.
Sir,
Okay,
hindi
natry-
ko papap yung ano?
Ha?
Sir, pag may naunang number before mag-shift log, hindi lalabas yung sa 10.
Bakit ganun yung calculator nyo eh?
Sir, yung dun sa lugar, mayroong circle, tapos, circle. Ano na yun? Square, tapos, parang logarithmic theorem lang din. Yung formula niya.
I-edit nyo siya as normal. Palitan nyo yung settings as normal.
Yung sa mode niya, sir.
Oo. So, para lumabas yung ganitong sagot. Okay. So, lalabas na yung 0.0641 mole. Next, meron ka ng mole. What's left? Para makuha yung weight. Ano ang gagamitin natin? So, nawawala yung weight. So, in order to get weight, mole times molecular weight. So, imumultiply natin itong value na to sa kanyang molecular weight. For aluminum fluoride, sa aluminum, isa, yung nandito, so 1. For fluorine, 3. Times their atomic weight. For aluminum, this is 26.98 grams per mole. For fluorine, this is 19 grams per mole. So this is equal to 20, 40, 60, 57 grams per mole. This is 26.98 grams per mole. Ipag-add natin, ang lalabas kapag pinag-add natin yan ay 83.98 grams per mole. So that means ang molecular weight ni aluminum fluoride ay 83.98. So imumultiply natin yung mole natin sa molecular weight, which is 83.98 grams per mole. Cancel mole, you will be left with grams. So 0.0641 divided by times 83.98, this is equal to 5.38 grams of aluminum fluoride. So this is now our final answer. So that means if you have 3.86 times 10 to the 22nd molecule of aluminum fluoride, ito yung magiging mole niya at ito yung magiging mass niya. Okay? Any question po? Okay, if there are none, do not forget to click on the poll for the attendance. the poll will be closed at 3 o'clock. Tapos, you can carry on your work with module number 10. Ang deadline po ng module number 10 ay until Friday para meron pa kayong time. Maliban dyan, reminder lang po na hindi naman siya required pero mas madali or mas maigi na during our quiz, make sure to make use of the periodic table of elements, yung actual, hindi yung software, para hindi kayo palit ng tab. Baka mamaya ma-close nyo yung quiz ninyo, kailangan nyo ulit mag-umpisa sa pinakauna. So please, kung meron kayong periodic table of elements, kung meron kayong printer, mag-print kayo. Pero as much as possible, susubukan ko na ilagay na yung kanilang atomic number at atomic weight doon sa questions para hindi kayo hanap sa periodic table. And then, you can also make use of your own calculators. Maliban dyan, sa phone kasi may setting dyan na after 30 seconds mong hindi gamitin, magko-close na yan agad or magte-turn off. So, pakialis na lang yung setting na yun para kung sakali baka mamaya nag-turn off yung screen tapos nag-quiz ka, pagka on mo uli, na-close mo accidentally, ulitin mo uli simula umpisa yung quiz. So, alisin yung settings ng screen timeout kapag nag-quiz. If you do not have any question, then you can work on your module. And the on-time submission is on Friday. So, yun lang po.
Pwede na mag-leave, sir.